Okay. So okay, so first we'll understand matplotlib. Okay, there are some principles of visualization. Some principles. Usually, the idea of visualization is to give a pictorial story to somebody. Okay, whatever data you have, you want a pictorial story to be given to somebody. Okay, and that story should be very minimalistic. Okay, it's not that you try to show everything. Something might be important, something might not be. Okay, so that will leave the viewer an impression of not clear about. When you see graphs, charts, and those things, right? The idea what they want to show you to is very clear. It's very simple. Okay, so before you feed your data to visualization library, that is where analysis is important. Okay, by analysis, what you're doing, you're trying to get crux of the information, and that is what you try to visualize. Right? That's the thumb rule. Okay, so convert your data into minimalistic information, then pass it to visualization. That is, if you see the best of the infographics, best of the graphs, best of the visualizations are really simple. So we'll understand from this aspect matplotlib import. Okay, so we have this matplotlib inline. Okay, now what does these two lines do? First line imports the matplotlib plotting library. Okay, second line actually this second line is a Jupyter notebook utility. What this second line will do, it will actually show the visualization in the notebook itself. Right, it will show the visualization in the notebook itself. Now let's take one by one all the points. Okay, this is the entire notes that is present here. Now what we're supposed to do, we let's create some data frame first. Okay, then we'll try to plot the data frame. Okay, so let's create df dot import pandas spd. This is the first column. First column will have the data. Right, you can see first column has this data from this. Now basically I would like to the range of data. So you have 10 to 20. Okay, so you have this data generated, and you also have column B, which is range 200 to 210, This is the entire data frame for you. Just for clarity. Now I want to plot this where the A column should be in my x-axis and B column in my y-axis. Right? That's the idea of plotting it. df dot okay, so the first way to plot is plt dot plot. First the x-axis, putting setting a little bit more time. Okay, so here df a y is equal to df b oh, maybe not E. First data. Yeah, that was a different data. So you can see here, this behaves as x-axis. But there are two columns in the data frame. First one is behaving as a x-axis, second one is behaving as a y-axis. Right? So if you have a very simple data set with x-axis as one information, y-axis another information, you can simply do this. PLT plot. This is the first column, this is the second column. No, x and y is required in this case. This is one way to plot it. Another way to plot it is directly using data frame. Yeah. So if you do df dot plot, right, it will automatically plot it. Df dot plot. Okay. Here this is the syntax. X is equal to A column, Y is equal to B column. If you do this, got it, right? Two ways of plotting. One is using plotting library, you are plotting it, whereas this is the data frame that you have created. Okay, mostly your data will be in data frame. So what you're doing here, using plot library, I mean matplotlib, this is how you have imported them. Matplotlib.pyplot as plt, this is how you have imported them. This is how you are plotting them with that library. This is one data, this is another data. Right? Of course, it is data frame in this case, it can be any other format of information. But if your data is in data frame, you can directly plot this. df plot, x-axis is A, y-axis is B. Is it clear? Okay. Now you want to give some, these are about label, title, X ticks and Y ticks. What is labels? These are information that you will give alongside of the data frame. Like if you see this data frame, you'll see this, these are ticks information. Okay, these are ticks. These are known as, these are X ticks, these are Y ticks. Okay, so let me show first ticks. lt dot X ticks. Mm-hmm. 2, 4, 6, 8. Can you see this 2, 4, 6, 8 coming in? By default, it was 0, 1, 2, 3. Now it is limited to 2, 4, 6, 8. Okay. Then you have X label, plt dot X label. Okay. This is the X label. This is X axis. You see this X axis? This is, now you want Y axis, plt dot Y label. Right, Y axis. This is coming here.
So the text can be anything, or it should be in the range only?
Huh?
The It should be in the
It should be in the range. I mean, of course, it can be outside it, then it will show it smaller. That also you can do, but the values should be in the range. I mean, that's what makes sense. And you have white text.
It is 0, 25, what is it?
Hmm?
Text, digital, syntax.
No, this is the output actually. It is coming from here. Okay, see, why I'm doing this, X text, Y text, right? 200. Like if I do this, 100, 190, 210, 230. You can see this is the impact of this, right? So now what you see this is here is like output of this. Like ideally, to plot the graph, you should do this. After doing everything, right? You should do plt.show. Okay, but since it is Jupyter Notebook and I have enabled this matplotlib inline, okay, it will not show that. Fine, right? Okay, now and if you want to do the same with the data frame, you can do it like this: df.plot. Two ways. Remember, there are two ways of doing it. One is with visualization. One is with data frame. df.plot x is equal to a, y is equal to b. So you have x sticks here. Well, you can directly pass the information here. X sticks 0, 3, 6, 9. Right? See this x sticks is coming here. Now, comma. X6 X label is also there, I guess. A legend is equal to true, you can do. It will show this is anyway showing the legend by default. X label is equal to title, plotting information. Right, you can see here the title of the graph will come. Remember, these are JPG image actually. If you want to save this data in a file, like you have this data, right? You can do this. ELT dot save figure. Just mention the file name JPG. Right, now you will see in the same directory it has created this file JPG. A.jpg. You notice this? Okay, so you have the data. You can plot the graph, save the graph. Okay, this graph you can put it as a part. You can see here the graph, right? So after you do everything, you can save it. The save fig, plt.savefig is the function. Right, fine so far. Okay. Now, like here is an interesting case. You can see here you have x square x cube, right? What you are creating? You're creating a data frame which contains x square x cube, right? And after this you are plotting this information. Plot. This is the first. See, in a graph you're plotting three things together. Many times you need to show this comparative analysis, right? Okay, this is one graph. This is another graph. This is another graph. I mean, all these things in the same graph with the different colors. Did you notice this? Then you have legend is equal to location center left. That is why it is giving here the left hand. What is the legend? Legend is actually this information. Got it right? Legend is this information. It is showing the size and shape of it. If you don't give it here, it will by default come here. Okay, legend. So you can see x is this graph, right? X square is this graph. X cube is this graph. You can see the difference between x square and x cube. How drastically they are different, right? Can you try plotting sine graph and cos graph? Okay, create from you have x column. You create a sine x column. You could create a cos x column. You try to plot both of them in the same graph and see the relationship. Yeah, maybe you can refer this. Create a data frame like this. Okay, maybe. So let's create the data frame. Let's create. So what are sign values 1 2? We can use this guy, right? So say for example x is equal to range 100. Then sin x is equal to import numpy as np. Okay, ed dot data frame x sin x and p dot sin right. This is x and sin x. Okay, now you can do cos x. Right, this is the data frame. Now what you want to do, you want to plot the graph plt plot. Can you see this? The okay. One is sine, but you don't know, right? What is sine, what is cos? So you can do this plot dot legend. Ah, no, no, it was not true. I think just legend you do. Yeah. So it will tell you sine, this blue is sine x, this is cos x, right? So I can actually do this 10. This is your sin x, this is your cos x prediction values. Kind of settled, right?
To get a smooth curve, you have to
Decimal range.
decimal.
I mean, those things you have to do. Yeah, you're showing a comparative. Here, legend, okay, you have a lot of options. Positions, yeah, we can throw the positions also here with legend. Location, LOC. Center left. CEM. Or maybe top left. Upper left, sorry. Got it, right? They're simply connecting the dots. But there are a lot of things we can do in graphs. Let me, now that we understand the basics, I'm going to show you. And right? Now that we understand the basics, let's quickly go to the difficult concept. So now here is color and line width. Okay, how do you control the color? Of course, by default, we have been doing it with default colors, right? Now, if you want to, control the color, okay, and you want to control the width of the plotting, right? You can do that. Df dot plot. So you have x and x, then color map. Colors. Okay, so you can see blue. Maybe if you want to, okay, suppose you simply do this now. See this graph? Does it make any sense? This is your x-axis. One is cosine axis blue. One is your sine axis, right? And if you want to show colors to them, color is going to be red, green, blue. Got it, right? See, the thing here is when you, as of now, I have been using two data and plotting them separately, right? This is a, you can see here, I'm using two data and plotting them separately, the old style. What I'm doing now is I have a, okay, I have the data. Okay, now I'm plotting it directly. Got it, right? I mean, you don't have to write all of them separately. From this is the x-axis, this is your y-axis, all the value. This is x is equal to y. Okay, this is x, this is sine x, this is cosine x. And this is your for x-axis. For this x-axis, I mean earlier what was x-axis? By default 0, 1, 2, 3, 4 it created, and whatever data you had, index became x-axis, and the data became your plot. Now what happened? The x becomes x-axis, and the rest of the data became your plot. Understood, right? Is it clear the difference between this line and this line? Is it clear the difference between this line and this line?
The y-axis has changed, right? Values of y-axis have changed.
No, here what has happened, your x column, there are three columns in the data, right? X is being treated as a x-axis now. If you do this, that is why only you have two data here, two. Okay. Whereas if you don't mention, x is equal to x, your index is taken as x-axis. Index column, data from index column. It also has 0 to 1, 0 to 50, right? 50 data is there. So that is being treated as x-axis. So you can say the x column with respect to the index column and other side. Understood, right? Okay, oh, and one more thing I wanted to show, line width.
The color we didn't choose, right?
RGB, red, green, blue.
But how do we get that? First is cosine is red and sine is green.
That is the data frame order actually.
No, first we plotted sine. But cos is First we plotted x, then sine, then cos.
See, cos, sine x, red, green, blue. I mean, you can control also which column. So you can. These are default controls. Default means it will use the default order. Got it, right? So that is where cosine became red, sine became green, and this guy became blue. If you have two things only, red and anyway, if you make it blue, you don't have blue here, red and green only. Understood, right? The same order it maintains in the order of the data frame. Now, I want to show the thickness also. Many times, before you do so, you need thickness. Line width.
So one thing, when there's a lot of data, like not the sine or cosine function, and we keep on increasing the width of the line or the points.
It will automatically increase.
It will show the mean.
then we have a lot of other type of plotting for that. It's not that this type of plotting is suited for all the data. Okay, we have a lot of other type of plotting. I'll show you. Okay, so a lot of other type of plotting. Then you have color map. Okay, color map is yeah. Okay, color map is different plotting schemes. Okay, you have lot of list of color. You don't have to give the method, give the colors independently the way we are doing now, right? We can give color map. So what are the possibilities? You can click here. I think yeah, you can click here. We'll find all the color map possibilities. See, you have this is a color map. If you tell Vides plasma, and remember the names because you don't want to check it again and again. Vides plasma, inferno, magma. Then you have this long list. If you choose this color options, all the colors will be of this pattern. Understood, right? Like our office color, mostly we use blue. So if I use this color combination, it will be working out for most of the stuffs. Right? Based on your product's color theme, you'll choose color scheme here. Color scheme. Okay. Understood so far? What are the various options? Okay. It's difficult to remember all of them in single shot, but to like whatever data we get later on, we'll try to manipulate it and learn more. Then you have grids. Many times you would have seen data like this, like to really show you the real picture, grids. So what you can do is plot grid through color M. M is your magnetic color that you're seeing here. Okay. So plot grid. LT. Understood, right? Upper left, and the color is blue. The blue is your block grid component, so that you can identify where is what. Now let's see various other options. Yeah, there's a question: what is the difference between PLT plot and DF plot? The PLT plot, if you do right, you get into do the plotting using matplotlib library. When you do DF plot, what happens is you use the data as an object and you are plotting corresponding to that. Okay, so if you do PLT.plot, this is why, because matplotlib is integrated with pandas by default. That is why this API would work. Okay, when you do PLT.plot, what happens over here is you have to pass the data. Here, along with the data, you are calling the plot, so you have to pass the configuration. Okay, so now let's now that was the previous plotting that we see, that was actually line plotting. Right, you're plotting the line. Now we will see, the bar graphs. Do you know why the bar graphs is used?
Draw inferences.
So let me generate the data. So pd dot data frame. Okay. Range. DFV. DF dot A into DF dot A, DF C, DF dot A, DF dot A. Right, so if you do data frame, it is this data. Okay. What I want to do, I want to plot this information, right? Bar graph. So I want to show the relationship between A, B, and C. Okay. So to do this, df dot plot sine bar. Okay, it will plot you bar graph. Notice this bar graph. Width I use just.
It increased, I think so.
Hmm?
It did increase.
No, no, some other API. Okay, so got the recent thing here. It is plotting the A is your blue, B is your orange, C is your green. Okay, and you can also do this
So if we
color map. Yes, it is. See the color combination changes. And these are your color map. Color map is a different color schemes. Like for example, you choose hot. Oh. Hey, you don't have to control anything. The other one is going as white.
So one thing, like for example, we saw that line width is not an attribute of this function. So when we want to find similar like variety of functions, do we use help function?
You can use help. You can use the documentation because as we see, libraries has huge list of.
So help is the
help is one way definitely. Okay. See here, I think it's doing it out.
Help and functioning.
Yeah, help and functioning. Just okay. So what is this? This is bar graph you're plotting, right? From df plot, right? You're plotting the bar graph. One way, other way to do this plt dot bar. Oh, I didn't do that. Let's combine all of them. This is A, B, and oh yeah, maybe that is the reason. Color. Red, blue. Yeah. So if I do C, red, blue, green. df.c. Right. Something wrong. Okay. Two colors. If it is three colors, then you are doing it like this. df dot plot kind. Okay, this is the bar graph that you are putting here. Then you have the option of subplotting. Subplotting means in one graph, you are plotting multiple things together, like this. Did you notice this? In one graph, you are showing multiple things together. This is known as subplotting. Okay. Suppose I'll tell you why this is useful. Suppose you have a target information and you have four features. You want to plot the relationship between all these four features and the target. How do you do that? You can plot that in the same graph, isn't it? Okay, four features and the target. You can plot all of this information in the same graph. Okay, that is where a subplotting is. Okay. Subplotting. So how do you do subplots? Okay, the syntax is a little tricky here. Okay, say in this case, I want to plot the relationship between x and x square and x and x cube. Okay, in the same graph, how many plots do I need? 2 plots. ELT dot subplot. Okay, PLT subplots. So here, for plotting this, here you will need number of rows as 1 and number of columns as 2. Right? That's what we need here, isn't it? We want to plot x with x square, x with x cube. Only 2 plots would be there. Okay. Number of row columns 2, number of rows 1. See, if I do this, it plots me this. Understood, right? Okay. This subplots return, actually, see this code here. This subplots return 2 objects. Just remember this. This is okay. One is the figure object, which is the complete object, and 2 sub objects, ax1 and ax2. Okay, this is ax1 is a way to control one subplot. Ax2 is the way to control another subplot. You can give any name. Okay, ax1, ax2 will be a tuple here, so you can actually. So the first one is fig. Remember this. Huh? First one is fig. This is the composition of all the things. Second is okay. So what you can do? Ax. If I do this, okay. So ax 0. Understood, right? If I do this ax, it will return me 2 objects. See, 2 objects. Got it, right? Okay. So if I want to access this first guy, ax0. Okay, I am writing any plotting information here. X0 and PLT dot plot A df dot A df dot B. See here, this is your AX0. And AX1 PLT dot plot DFA comma DF dot C. Oops.
You're executing both of them together, no?
That's okay. X2 X1 X2. Why is it plotting both of them in the same place? So plots. Here apparently what is happening, both of the information are going to this subplot. 2 rows, 2 columns. This is fine. Oh. This is possible only when this interpretation has gone wrong. The n rows is 1. A, B, C is A.
I think your battery is going down.
Yeah. A, this is B, right? This is with A. This is with B. What was wrong here? The only thing I was doing is that's not required. Number of columns, number of rows. No. Any idea what was I doing? The only thing I think that's okay. Okay, try doing this. So understood, right? So this is your subplots. This was I don't see any difference. Might be I have to re-execute it again. Okay, so here that's your subplots. You're doing 2 columns, 2 columns, 1 rows. If you make it 2 cross 2, it will be 4 rate like this. Okay, and here AX3 4 expected for what 2?
The AX1 dot plot you have to give 4 values. Right?
Hmm?
You don't have to give 4 values. DFA, DFB.
Not enough well to unpack. Expected 4. What,
Yeah,
how did it got to it? Single 4 only.
In the next 2 lines.
Even if I don't give, it's not a problem. Some this API I think has undergone little changes here. Not enough values to unpack.
So one thing per AX1 dot plot we have to give 4 values, right? Because
Why?
we have given 4 subplots.
No. See, these are your subplots.
Okay.
Okay. The other way to do this is like this. It was earlier there. Let me check it. Give me a change. If I do like this. Right, if I do like this. Okay, this is fine. If you want to add something in AX0 and all,
Okay, that will have to
see this. See, if you see AX, see here. If I do AX, understand this, what is happening now. If I do this, there are 4 subplots here, right? 4 sub, and what is the matrix dimension of it? 2 cross 2. Understood, right? So if you have to access some of the values here, you basically have to. This was the correct step. scatter df.a, comma df.b. This is being treated as 0 cross 0.
Okay.
Right. So this is what I wanted to check now.
Okay, 0 cross 0 should be the first one, right? The first graph.
I think the latest library has some problems here. It's not able to separate things out unless I'm doing that. Okay, but this is how scatter works basically. I mean, this is how the subplotting works. There is something to do here. AX1.
Can I please remove that plot?
Which one? Huh?
Plot. Is equal to plot. I'm getting like this.
Is equal to plot. Oh. Okay, yeah. Oh, sorry, yeah. Yeah. Right. Okay. So what you this is absolutely. So what it is doing, this is actually returning the tuple, okay, which contains all the subplots information. Right, all the subplots information. What does it has? If you see what I'm dumping here, it is actually a 2 cross 2 matrix here. Right, 2 cross 2. All the subplots, because you are giving here 2 cross 2. Right. Now what you want to do, you want to access each of them and configure some values, as you're rightly saying. Okay, so here this is the first data and you're plotting this. If you want to plot normal line plot, right, you do this. It will be changing this information. Normal line plot. Right? If you are plotting a scatter plot, you are changing this information. Okay. Then you want to change the third guy. It should be 1 and 0, isn't it? 1 and 0. Df dot A. Right? This is a third plot. Okay. Now again you want to plot a scatter plot for that. Scatter plot. Should do right. I understood the concept of subplotting. How do we access it? What does each of these elements mean? Okay, so this is the subplotting concept. Okay, so these were like the heart of the concepts that we will see in this area. Now, okay, the next thing is scatter plotting. Okay, scatter plotting is, suppose this is a very interesting data. This is your advertising CSV. Okay, there is some information, advertising information. Now you can see here. Just pay attention here. So this is a very good way to understand the pattern of information. This is TV information. Maybe number of viewers of TV, number of listeners of audio, newspaper, and total sales. Okay.
One thing, like it's like it might be sounding very weird question, but like if the data is in decimals, do we understand that it cannot be number of people, or it can be number of people?
See, it can be logarithmic value of total people.
Okay, that's possible. So we cannot like say that okay, this data is incorrect.
We cannot say that unless we know it is a number of people. Okay,
Because
it can be log scale.
We avoid understanding as whole.
Well, absolutely, but this can be log scale. Okay. When you talk about population, you generally work on log scale, because unless it will be million, trillion, it's difficult to plot it, right? Okay. This is some advertisement file. Okay, so you can see this is TV patterns here. This is radio pattern here. This is newspaper pattern here. Understood, right? Okay. I'm just thinking what I can show now. So scatter plot. See, if you are plotting this scatter plot, this is the sales information. X-axis is sales, Y-axis is data. Right? You can see this is the sales. This is actually sales information. Sales data. You are plotting it as a scatter plot. Right? You can plot this data for any scatter plot is useful for plotting any continuous information. Of course, you can do normal discrete information as well, but more useful for continuous information. You will plot a trend for you. I have some thing to show. Yeah, let me load it. This is a very popular import.
Currency comparison is also.
Currency comparison. You can do any. So like here, I'll compare plot satisfaction level. Okay, I'll plot satisfaction level. Okay, and then we'll see it. Here it's CSV. Data. Okay, so this is the data frame. Okay, and you can see that this is basically employee data, EMP. Okay, here you have you have the satisfaction level. Okay, satisfaction level, and also you have this left column, right? You have left column. So now I want to plot the data based on satisfaction level and left column. Okay, and want to see what is the scale here.
Satisfaction level and left column is that index.
No, left column is whether the person left or not.
Okay.
Okay, so ELT dot scatter. ELT dot
X, Y, I think it is.
It's not plotting the data. And spent in a company is also one column, right?
Actually, I think it is, but the values all are in zero values.
0 and 1. I mean, here this is time spent in a company. Still, it's not showing that information. Let me get there. Okay. Yeah, that's. I have to do some group by information. I will just show. There's a visualization. Employee data visualization. Okay. There were some cases that we did. See this. This is the same data. Okay. Just that we after plotting this information, yeah. This is first we are plotting a bar graph with department, right? See this data. So here we are actually I need to do group by here. So you are doing a group by based on department. You are plotting that information, and this is what shows you that sales has lot many people compared to any other department, right? You can see group by department, and then the data you are plotting out. Okay. Then, of course, this is time spent in a company which is same. Oh, yeah, this was what I was talking about. Oh, satisfaction level, average monthly hours. Yeah, that was okay. So, see this data. So, you have satisfaction level, average monthly hours. If I do this data, it's not making a lot of sense, right? But you can see one thing. Okay, I will see a better representation of this data also. Okay, and there is one thing. Size S is equal to 1. Yeah, it means the size of the dot, right? What do you see here? This is your ELT dot. What is this? This is your satisfaction level, which is between 0 and 1. X label. That is ELT dot Y label. See this. So what does it tell you? What does this graph tell you? Dense means there are more populace of that. So what does this graph tell you here? This is higher satisfaction level, right? And this is monthly hours. And there is some density here, there is some density here, there is some pattern, right? This is some pattern here, this is some pattern here, this is some pattern here. What does this tell you? I mean, I got to make a story here that, when the satisfaction level is more, then see, when the average working hour is more, hey, Ulta. When the average working hours is more, see this data here.
Yeah.
This is one pattern, right? When average working hour is more, the satisfaction level is very less. And isn't this true? Right? People who work less anyway have higher chances of being more satisfied.
But that section that is being quite, the section is being quite evident and uniform.
Yeah. So this is one bust of people who work really hard. Okay, you can see they're above the major masses who work really hard. So of course, when you work hard, your expectation from the company is higher, right? And of course, as an organization, it is always difficult to meet that, right? You have higher chances of being unsatisfied. You work average. That is what a company actually wants. You work average. Okay. Your satisfaction level will be higher because you'll be working as per company's expectation. Your expectation from company and company's expectation from you will be a match there, and you are more satisfied. Right? This is the inference you make out of this visualization. Right? So these are some more things. Okay, I mean, see, if that was the case, that is very difficult to understand the previous data, right? So you have another type of plotting that is known as hexabin, xbin. Xbin is, you can see this sort of plotting. So let me do that. Right, you are not able to see which one is better. It looks more denser, but if you want to really see, when it is hexbin, it is grid size. World color map. BUGN. BUGN. What is it containing? No parameters. Unknown property color map. C map, C map. Yeah, C map. Okay, can you see this one thing here? So it tells you that this is the distribution. This is another thing that you need to know, that people who work less also might have less self-satisfaction, because they anyway people who might quit basically. Understood?
The color combination also, now it shows that this section is the
most prevalent. This section, some section here is more prevalent. Yeah. This is not that. I mean, this is okay. You are okay with this section.
The other graph that was looking in the blue one, that was scatter plot.
Because you don't see the color difference there, right? You don't understand the gridness of it, the measure of it.
And what is hist plot? Is it
histogram? Histogram is a frequency distribution. I'll show it now. Okay, understood, right? What is this plot? Scatter plot. Of course, size is the one that I just described you, dot size. Color, you can control the colors. You see here, different color for different information. See. Okay, C map for color mapping information.
In this, can we set a bar as well, like above 300 if any values are there with this bar?
You can, better you do that with data cleaning. All those things. You can mention a marker also here. See, take a note, marker. Can you see it from there? Marker. O means is 0, which is default. Marker, if you do plus, some data will be in plus. Okay. If you put triangle in this guy, it will be triangle. Understood, right? Markers. They are known as markers. This is very exhaustive details that we have it here. Then CMap is a color map option that we just discussed. Okay. Okay, so don't get overwhelmed by the visualization. That is important thing to understand. There is a lot of libraries, a lot of things. You, as of when we start, you get a fundamental understanding of it, so that if you're not aware of something, you can go and check. Okay, but there is a lot of these options here. Like one is alpha. I'll tell you the useful ones. Alpha. Alpha. What alpha does is it actually controls the color. Alpha 0.5. You can see it lightens the color, isn't it? If you make it, it will make it very light. Understood? Okay. So if you, I mean, things get more even now. This is denser, and all that. That is your alpha. Okay, line width we have seen earlier, which controls the line, width of this data. Okay, if you want to do plot from a data frame, you can do plot, data plot, scatter. Okay, and it is plotting the data frame x-axis and y-axis. Let's go to the next one.
And
One thing, what is that norm?
Huh?
What is that norm? I have just seen in the page. There's one norm where we said it true.
Norm.
Yeah. Little bit up.
H alpha norm, this one. So this is what is this does is this scales the data between 0 and 1. Okay, so whatever data you have, it will normalize it. Okay, but this is not the best. I mean, this is definitely one option that you have here. Norm is equal to true means it will bring the data. See here, whatever data you have, right? It will bring the data in the scale of 0 and 1. This is some technique that we learn. We'll understand why normalization and all. This is part of our pre-processing topic actually. Okay, why do you normalize data? So that, see, understand, if your data is too huge, what will happen? Your this scape will be difficult to plot the data, isn't it? So what you need to do to make you want to convert, normalize the data between 0 and 1 so that you can plot it easily. Got it, right? So this is normalization. This is see, if you like, for example, if I say that the value for a particular field ranges from 1 to a huge number, if you're trying to plot it, it is a difficult task, isn't it? Okay, so what is the another way to do it? You convert the number between 0 and 1. How will you do that? Using any of the normalization technique, which can be as simple as finding the maximum value, minimum value, dividing with the difference. Right? These are known as normalization. So you can normalize here also you can normalize the data that you can pass to the scatter plot. That is a norm. Though not very useful, because if you want to do all this normalization, you would do with the pre-processing library, then you pass to the normal plotting graphs. But you have a provision like this here, right? Plotting norm.
Okay, thanks.
So you have next bar graph, bar and bar H. Okay, quickly see here. So you have this particular data, right? This is income data. You can see this data. This is income data. Okay, if you want to know where is this data, you can actually click here. Okay, there will be an adult file. You can see this adult data here, isn't it? This is the adult data that we are trying to plot here. This is adult data. So if you are plotting, here what I'm plotting, age versus count. So what is it? This is a bar graph here. You can see the data consists of people who are in the age of 20 to 50 more. Understood? Because the more major working class falls here. That is your bar data here, bar. If you want to plot bar h, it is like this, horizontal, right? PLT dot bar h. This is the value counts. Okay, age value count. This is the the index, the data. Okay, so let me plot it. Like in my this data, I have three categories of income: low, medium, high. Okay, three categories of income. Okay, pandas, sorry, pd dot read csv. CSV data and okay, you can see this first and you have all this data here. The first, this does not have header names, right? So what would I do? I'll just copy paste this piece of stuff. I want to assign some header names to that. Understood, right? Parsef for an unexpected argument. Oh, header is good to know. Names. Yeah. So see, we have the data frame here. Right, we have the data like this here. What you want to do, you want to plot it based on this guy. Okay, age. Values. Value forms. age dot value counts. Right? It will should tell you for a particular age how many frequencies is there. Now this is the information say you want to plot. Okay, that is age by working class population. So what do you do? Not bar. This is the index information column and then data dot age dot value counts. Okay, can you see this? This is the age-wise plotting. If you want to just plot it horizontally, bar age, horizontally. Fine. Okay. Similarly, this is a horizontal graph and all that. So it's up to you. You can plot, I mean, male, female, gender ratio. Okay, from the same data. Okay. Again, if you get an option to give different color to different columns here, right? Say for example, this is the male female, ratio over here. Okay. So if I do it, what is the column name? Got it right? Okay, I want to give different color to different gender. Okay, color. Blue. Understood, right? Different color information here. Let's see more. And bar graphs, sometimes you want to give edge color. Are you seeing this? Edge color. You can configure edge color is equal to whatever color you want to give, blue or whatever. Line width, control the size of the edge. Okay. Then basically, that's this is very useful actually. Here, okay, you can. This was one way. Another way was you can plot it directly from the data itself, right? Data column value counts. This is what you want to plot. Dot plot bar, and this is x-axis. This is, index becomes x-axis, values become y-axis. Got it, right? Okay. So you can try this out. See if there are more. I mean, it's pretty much around this edge.
I don't think it is data.
This, which data? This data I showed you, right? It is inside this. So this is inside this. Inside machine learning for beginners, okay, you have data folder. Okay, so you have adult data here. This data. That gives you this information here. Last thing for today is pie chart. Okay, pie chart, I think more or less everybody has seen it. Okay, now the question that should come in your mind, when should you use what type of plotting? Right? So pie chart is for showing simple information. Like, if you see here, this is like different states and the companies in the different state. Okay, you want to show the distribution for them. What you can do is you can create plot.py x dot, this is the data. It's but one column. You have only one column and it is showing the distribution. So pie chart is useful is plotting categorical data. Right? I mean, basically, say you have this, Telangana has this many information. So if you are plotting, this is the value corresponding to which it will plot, and this is the categorical data here. So if you have this sort of information, then you should be plotting pie charts. Right? Scatter plot is mostly meant for continuous values. Understood, right? Okay, and remember, pie chart is okay, good for smaller data. Larger data does not make a lot of sense. You can plot. You can see this sort of ability. Looks good, isn't it? Right? If you're talking about, like, for example, elections is happening, or something that is of concern, you can do this. Okay. Okay, this is the normal data.
What is the explode function?
Takes an array values which specify the fraction of length and radius. Okay. So this is this data which comes out. Got it, right? It is this data.
So it's about the part of 360 degrees.
Yeah. So how this data is coming out, basically. Right. This time you are giving different color here. This part is coming out. Explode.
And these pie charts are generally on an angle. They are not top facing. If you see Tripura, it's not even visible. But I think it is because of the angle.
No, maybe the data is very less. Okay, the data is very less. Okay, you can also control. This guy. Percentage, auto percentage. Right, you can see that 6 is just 0.3%. Okay, this parameter auto PCT. Right, this controls what is the percentage distribution. If you want to give 3D effect, you can do that with shadow. Okay, you can increase the shadow and all that, but 3D effect is given using shadow. Okay, we'll check out some options here. If you want a bigger graph, then you can. This is the line width, this is the center, percentage distance, label to start angle radius. Right, this is telling you 100% of the information, and you can see you are plotting this particular information here. Rotate angles. Okay, if you have a lot of other information, okay, you can do that, but differentiate all the information. So this is whatever content you are seeing. This is like a superset of auxiliary. Okay, so the idea is to understand the foundations, and later on, as you proceed, you will start using more and more utilities of this class. Okay. So area plot histograms is one useful thing. Okay, histogram. What is histograms? Generally, histograms is for frequency distribution. Right? For a particular data, whatever is the frequency, you see histograms coming out here. Right? Histograms is frequency distribution. Okay. Like just okay. So if you do this is the data here, right? A, B, and C, and these are the columns. if you do PLT histogram, and it is all random value, histogram, BBA, B and C, it is just plotting you the frequency. This is the data here, -4. This is the data. And this is the height of the graph. Histogram graph here shows what is the frequency of it. What is the frequency of the data? Here it shows that the central data has more frequency, right? That is because it is normal distribution, random. What is normal distribution?
Normal means
bell curve. The data is more centralized, right? Towards centralized data, 0 is by default, right? That is a central distribution. Right here, if you are controlling the number of bins here, how many buckets are you breaking the data into? Understood, right? If your bins are too small, the height will be lesser. If the bins are too thicker, it will more. Right? This is your bins.
so that bins function is actually changing the range also.
Bin function is deciding how much data should be falling in one bin set bucket size. Okay, there's a range of data that will be falling in one bucket. That is what bin is. Okay, let me get back here. Okay, you understood what we did here, right? Okay, tomorrow, what will I do? I'll take up some practical data and I'll try to use all the utilities that you have learned. Okay, like this, what we did with the previous batch here. Okay, that will connect all the dots that you have. See here, this is what? This is for different team. I'm plotting this distribution here, isn't it? It tells you that sales has lot many people. What is this? This is working hours. You can see all of them is almost working in the same number of hours, right? And how do you do basically this? Okay, so PLT.y subplots true because two subplots, 16 and 16 by 8. Total we have taken 16 is the size entity. 16 by 8 is one graph. Right? This is your bar graphs. Is it clear?
One thing when in this function when we do AX and it gives an array, so what do we understand from this?
So AX means this is one subplot object, this is another subplot object. If you want to write in this subplot, you will do AX 0 dot plot or 0 dot scatter. Okay. You will use that object. I mean, I was trying to override that object. Okay, it was the style sometime back used to work. In the new library, this won't work. It is overwriting the last object. That's the reason when you asked the last, subplot getting all the value, that's because it was overwriting it. If you want each subplot to show the value, you have to work on AX0 dot plot, pass the value over. Fine, right? Play around with all these things. Okay. Get a working understanding. I think we have discussed more on the concepts part. Okay. How to deal with it. There are a lot of libraries. If you want something, you can just refer the documentation, see how they are doing it. But we'll solve some problems tomorrow. We'll be using some original data, solving some real problems. Okay. So we'll do data analysis on it. Okay. So tomorrow we'll basically we'll get the data. We'll do data analysis on it. Then we'll plot it. Then we'll, like we did here for employee data, right? We'll do that for some other data method to understand what is happening with the data. To understand, we will be doing basically data analysis of it. Okay, that's all for today. Let's catch up tomorrow.
So I just want to know the Friday class, is it possible to shift it to the next week?
Friday there is something.
No, like I won't be able to attend.
Oh, you will do some other things. This one you or something?
Actually, this week is. I was just thinking if it is. I don't need extra on that.
Oh, you are extra.
I
don't think so because where will you can record?
Oh no. Actually, there's some new complication. The class would be happening. We cannot shift it to the next week.
Difficult because everybody would have planned things accordingly. Right?
every day for people.
Oh.
So I just wanted to make the most to the